So yesterday we have completed the bases and how acids are combining with the bases to form salt and water, and the reaction is called a neutralization reaction. We completed up to that yesterday. Now today what we are going to do is how the acid reacts with the metal oxides. See, when you add metal oxides like zinc oxide or carbon dioxide, sodium oxide, if it is added to HCl. Suppose you add sodium oxide to HCl, what will you get? You will get sodium hydroxide plus sodium chloride plus water, salt and water. Sodium chloride is salt and water. So if you add sodium oxide to HCl, you will get sodium chloride and water. You see, hydrogen is substituted by sodium. So you got salt and water. Potassium oxide, K2O, if it reacts with the, or if it added the sulfuric acid, you will get potassium sulfate, the salt and water. Salt and water. So if potassium oxide, metallic oxide, is added to an acid, you are getting salt and water. So these are all metallic oxide, these are all basic in nature. That is why they are adding, they are reacting with acids to form salt and water. So metallic oxides react with acids to form salt and water. So metallic oxides are basic in nature. They are basic in nature. Therefore, they are called basic oxides. Basic oxides. So metallic oxides are usually basic oxides. They react with acids to form salt and water. And what about the non-metallic oxides? You have studied when non-metallic oxide, carbon dioxide is passed through lime water. The last chapter we have seen. Carbon dioxide, it is a non-metallic oxide. Carbon is a non-metal. Carbon dioxide, if it is passed through calcium hydroxide, that is lime water, you get calcium carbonate plus water. Calcium carbonate plus water. That is also a salt. Calcium carbonate plus water. So this is again salt and water. So if a non-metallic oxide is passed through a base, you will get again salt and water. So non-metallic oxide, this is acidic in nature. That is why it is reacting with the bases to form salt and water. Sodium hydroxide, NaOH. If you pass sulfur dioxide, you will get Na2SO3 plus H2O, salt and water. Again, this is also salt. So sulfur dioxide is a non-metallic oxide. It is reacting with a base to form salt and water. So non-metallic oxides are acidic in nature. Understood? Non-metallic oxides are acidic in nature and metallic oxides are usually basic in nature. I won't say all the metallic oxides are having basic nature, but most of them are basic in nature, and I cannot say all the non-metallic oxides are acidic in nature, but most of them are acidic in nature. So metallic oxides are basic in nature. They react with acids to form salt and water. Non-metallic oxides, most of the non-metallic oxides are acidic in nature. They react with the bases to form salt and water. Okay. Now next question is, what is common? We have studied yesterday acids, on when you dissolve them in water, they give hydrogen ions in solution. Whereas bases, when they dissolve in water, they give hydroxide ions in solution. Do these have anything in common? Acid solution and basic solution. Suppose I am adding HCl to water. HCl is added to water. Now water contains H2O, even if it is a very weak electrolyte, it is having H plus and OH minus ion. It is having H plus and some of them are dissociated to give H plus and OH minus ions. So when you add HCl, this HCl give also H plus ions, isn't it? So concentration of the H plus ions will increase, but OH minus ions will be there. So an acidic solution means a solution in which H plus ions are having higher concentration, or H plus ions concentration is high. Then what about alkali? If you add NaOH, then OH minus ion concentration will be very high. So concentration of OH minus will be higher than H plus. So it is basic in nature. So if you add acid in water, it will dissociate to give hydrogen ions. Yesterday we have said they will combine with the remaining water molecule to form hydronium ions. But hydronium ions are there, and that is H plus ions are there, then the remaining OH minus will be there. But hydronium ion concentration is much higher, so solution is acidic in nature. When you add an alkali, OH minus ion concentration is very high, so it is basic in nature. Understood? Now we will come to, yesterday we have seen any acid or base, they will give H plus and OH minus ion solution. Now when you dilute an acid or a base, when you dissolve acid or a base in water, what happens? When an acid or a base is dissolved in water, the dissolution process is a highly exothermic change. നമ്മൾ വെള്ളത്തിലേക്ക് അല്ലെങ്കിൽ കുറച്ച് ആസിഡിൽ വെള്ളത്തിലേക്ക് കുറച്ച് ആസിഡ് ഒഴിച്ച് ഇങ്ങനെ നോക്കിക്കഴിഞ്ഞാൽ it will be very hot. The temperature of the test tube will be very hot. അതേപോലെ ഒരു ബേസ് സോഡിയം ഹൈഡ്രോക്സൈഡ് വെള്ളത്തിലോട്ട് ഡിസോൾവ് ചെയ്താലും the test tube will become very hot because dissolution of acid or base in water is highly exothermic. Exothermic എന്ന് പറഞ്ഞാൽ heat energy is evolved, അല്ലേ? Heat energy പുറത്തേക്ക് വിടുന്ന ഒരു റിയാക്ഷൻ ആണ്. ഏത്? dissolution of acid and base. ഇപ്പോൾ വെള്ളത്തിലേക്ക് ആസിഡിൽ ഡിസോൾവ് ചെയ്താലും ശരി, ബേസ് ഡിസോൾവ് ചെയ്താലും ശരി, ഒരുപാട് ഹീറ്റ് എനർജി ലിബറേറ്റ് ചെയ്യും. സോ അത് ഹൈലി എക്സോതേർമിക് റിയാക്ഷനാണ്. അങ്ങനെ ഹൈലി എക്സോതേർമിക് ആയത് നമ്മുടെ ഒരു ടെസ്റ്റ് ട്യൂബ് എടുത്തിട്ട് അതിനകത്ത് കുറച്ച് വെള്ളം എടുത്ത് അതിനകത്ത് 2 ഡ്രോപ്പ് ആസിഡ് ഒഴിച്ച് നമ്മൾ അടിയിലൊന്ന് തൊട്ട് നോക്കിക്കഴിഞ്ഞാൽ ഇറ്റ് വിൽ ബി വെരി ഹോട്ട്. അതേപോലെ ഒരു പെല്ലറ്റ് സോഡിയം ഹൈഡ്രോക്സൈഡ് എടുത്ത് കുറച്ച് വെള്ളമൊക്കെ ഒഴിച്ചൊന്ന് തൊട്ട് നോക്കിക്കഴിഞ്ഞാൽ ദ ടെസ്റ്റ് ട്യൂബ് വിൽ ബി വെരി ഹോട്ട്. എന്തുകൊണ്ടാണ്? ബിക്കോസ് ദ ചേഞ്ച് ഈസ് ദ ഡിസൊല്യൂഷൻ ഈസ് എ ഹൈലി എക്സോതെർമിക് ചേഞ്ച്. വളരെ ഭയങ്കര എക്സോതെർമിക് ആയിട്ടുള്ളൊരു ചേഞ്ചാണത്. മനസ്സിലായില്ലേ? അങ്ങനെയാണെങ്കിൽ നമ്മളൊരു ആസിഡ് ഡൈല്യൂട്ട് ചെയ്യുമ്പോൾ വളരെ ശ്രദ്ധിക്കണം. വിൽ ഹാവ് ടു ബി വെരി കെയർഫുൾ വെൻ വി ആർ ഡൈല്യൂട്ടിങ് ആൻ ആസിഡ്. ആസിഡ് നമ്മൾ ഡൈല്യൂട്ട് ചെയ്യാൻ എപ്പോഴും ഓൾവേസ് വാട്ട് വിൽ ഹാവ് ടു ഡു ഈസ് ആഡ് ആസിഡ് ടു വാട്ടർ. ആസിഡ് കുറേശ്ശെ ക്വാണ്ടിറ്റി ആയിട്ട് വെള്ളത്തിലേക്ക് ഒഴിക്കണം. വെള്ളം ഒരിക്കലും ആസിഡിലേക്ക് ഒഴിക്കരുത്. മനസ്സിലായല്ലോ? യു വിൽ ഹാവ് ടു ആഡ് ആസിഡ് ടു വാട്ടർ. 1 minute I will show you one change. See, I have taken acid, a little bit water here. You see, when I am adding acid here to this water, this is concentrated sulfuric acid I am adding. See how heat is coming up. Now if you touch the temperature, it's very hot. I cannot touch it. It is really very hot. Why it is very hot? It's a highly exothermic change. See, instead of adding acid to water, if I am adding water to acid, what will happen? This acid will jump out from the test tube and it will spill around, causing burns. So you should not add water to acid. Always you add acid to water. When you are adding acid to water, the temperature which is formed will be absorbed by the surrounding water and this spilling out will not happen. So always when you dilute an acid, you must be very careful. You will have to add acid very in small quantities. Acid must be added to water in small quantities, and you will have to cool it simultaneously. That's how we dilute an acid. Understood? So this is how acids are diluted, and this is this one. Now we will come back to acid base reactions. Some acids are very strong, we say. Some acids are very weak, and some acids in our stomach, we say. Some, if you add more spicy food, then acidity is there. Acid is more in stomach, isn't it? So acid and base strength, or concentration of the strength of acids and base, we can measure in using a scale. That scale is called pH scale. The scale to measure the strength of acid and base is called pH scale. See, when I am teaching the pH scale, I will go through certain things which you don't know. See, water, I told you, it is a very weak electrolyte. It will not split into ions, but it will split to a lesser extent. It will split to H plus and OH minus. Very small amount of water will split into H plus and OH minus. But in neutral water, the concentration of H plus ions will be equal to concentration of OH minus. Whatever amount of H plus is formed, that much amount of OH minus is also formed. It is all, they are equal in ordinary water. And the concentration of H plus is X and concentration of OH is X, and the product of H plus and OH minus ion concentration equal to 10 raised to minus 14. H plus ions concentration into OH minus ion concentration is equal to 10 raised to minus 14, and this is called the ionic product of water, and it is always a constant. This is always a constant. Product of H plus ions and OH minus ions is equal to 10 raised to minus 14, and that this 10 raised to minus 14 is always a constant. You add any amount of acid or any amount of base to water, this 10 raised to minus 14 will remain a constant. H plus കൂടിയാൽ OH കുറയും, OH കൂടിയാൽ H plus കുറയും. Product എന്തായാലും എപ്പോഴും എന്തായിരിക്കും? 10 raised to minus 14. Understood? So x into x is equal to x square, that is equal to 10 raised to minus 14. What is x? X is equal to square root of 10 raised to minus 14. That is equal to 10 raised to minus 7 moles per liter. That's where we have studied. So concentration of H plus ion is 10 raised to minus 7. Concentration of OH minus ion is also 10 raised to minus 7. In neutral water, they are all equal. Understood? Now, what is pH? pH is the constant. pH is potential hydrogen. It's a hydrogen ion concentration. That is called a pH. How much hydrogen ion is there? Now, suppose this the pH is, how to calculate it is actually negative logarithm of hydrogen ion concentration. There is no hydrogen ion, so usually hydronium ion is formed. So we write like this. It is negative logarithm of hydrogen ion concentration or hydronium ion concentration. Now, what is logarithm and all? No need to know that. But I will tell you one thing. Logarithm of 10 raised to minus 2 is equal to minus 2. Logarithm of 10 raised to 1 is equal to 1. So log value of number is its exponential, that's power. Log of 10 raised to minus 2 is minus 2. Log of 10 raised to 1 is 1. Understood? That must only you know. Now, then what is the pH of a neutral solution? pH is equal to negative of log H plus ion concentration or H3O plus, for both are same. That is equal to minus of log of 10 raised to minus 7. That is the concentration of H plus. Log of 10 raised to minus 7. Log of 10 raised to minus 7 is minus 7. Minus of, that is equal to minus of minus 7. That is equal to plus 7. So pH of neutral water is 7. Understood? pH of neutral water is 7. That is ordinary water. It is 7. Now suppose you add a little bit HCl to it. A little bit of HCl is added. Now when water only was there, the concentration of hydrogen ion is 10 raised to minus 7. Isn't it? Hydrogen ion concentration when neutral, it is 10 raised to minus 7 in neutral water. Now we added some acid. We have added some acid. Now the concentration became 10 raised to minus 5. Which is greater, 10 raised to minus 7 or 10 raised to minus 5? It is 10 raised to minus 5. So, neutral water pH is 7 ആണ്. Hydrogen concentration 10 raised to minus 7. അതിനകത്തേക്ക് ഞാൻ കുറച്ച് HCl ഒഴിച്ചു. Now I added some HCl. Now the concentration of hydrogen ion increased to 10 raised to minus 5. അത് കൂടി 10 raised to minus 5 ലേക്കായി. അപ്പോൾ ലോഗരിതം എന്തായിരിക്കും? Logarithm is pH is equal to minus of log H plus, that is equal to minus of log 10 raised to minus 5, that is equal to minus of minus 5 plus 5. So pH is now 5. Acid ഒഴിച്ചപ്പോൾ നമ്മൾ അങ്ങോട്ട് acidic ആയി, അപ്പോൾ pH കുറഞ്ഞാണ് വരുന്നത്. അപ്പോൾ as pH decreases, pH value decreases, the strength of the acids will increase. Acid കൂടുതൽ strong ആകുന്ന അല്ലെങ്കിൽ acidity കൂടുക എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ pH value കുറയാനാണ് അർത്ഥം. So when pH value decreases, the acidity will go on increasing. മനസ്സിലായോ? pH 1 ആണോ pH 5 ആണോ കൂടുതൽ acidic എന്ന് വെച്ചാൽ pH 1 ആണ്. കാരണം എന്താ? അത്രയും 10 raised to minus 1 ആണ്, അത്രയും കൂടുതലാണ് ഹൈഡ്രജൻ അയൺ കോൺസെൻട്രേഷൻ. മനസ്സിലായില്ല? സോ അപ്പോൾ pH value കുറയുന്നതിനനുസരിച്ച് acidic character will increase. അങ്ങനെയാണെങ്കിൽ base, suppose instead of adding acid, I added some sodium hydroxide. Neutral water sodium hydroxide concentration, OH minus concentration is also equal to 10 raised to minus 7. Neutral water ആണെങ്കിലും അതിനകത്ത് OH minus concentration എത്രയാണ്? 10 raised to minus 7. ഇപ്പോൾ ഞാൻ എത്ര ആഡ് ചെയ്തു? കുറച്ച് സോഡിയം ഹൈഡ്രോക്സൈഡ് ആഡ് ചെയ്തപ്പോൾ now the concentration is 10 raised to minus 4. Let the concentration is 10 raised to minus 4. എത്രയായിരിക്കും pH? Now pH നമുക്ക് കാണണമെങ്കിൽ എന്ത് വേണം? നെഗറ്റീവ് ഓഫ് log H plus വേണം. വേണ്ടേ? But H plus concentration is not given. OH minus concentration ആണ് 10 raised to minus 4 തന്നിരിക്കുന്നത്. H plus into OH minus multiply നമുക്ക് എന്ത് കിട്ടും? 10 raised to minus 14. H plus concentration into OH minus ion concentration is equal to 10 raised to minus 14. നമുക്ക് OH minus concentration 10 raised to minus 4 ആണ്. So H plus into OH 10 raised to minus 4 is equal to 10 raised to minus 14. What is H plus ion concentration? That is equal to 10 raised to minus 14 divided by 10 raised to minus 4, that is equal to 10 raised to minus 10. അപ്പോൾ H plus concentration എത്രയുണ്ട്? ഇപ്പം 10 raised to minus 10 is there. അപ്പോൾ എങ്ങനെ ഞാൻ ചെയ്തത്? ഞാൻ 10 raised to minus 7 ആയിരുന്നു ന്യൂട്രൽ വാട്ടർ. അതിലേക്ക് ഞാൻ എന്ത് ആഡ് ചെയ്തു? കുറച്ച് ആൽക്കലി ആഡ് ചെയ്തു. ആൽക്കലി ആഡ് ചെയ്തപ്പോൾ എന്തായി കോൺസെൻട്രേഷൻ? OH minus ion concentration ആണ് കൂടുക, H plus അല്ല. Because alkalis give OH minus ion. OH minus ion concentration 10 raised to minus 4. അപ്പോൾ നമുക്ക് pH എന്താണ്? H plus ന്റെ concentration ആണ്. നമുക്ക് OH minus ന്റെ concentration അറിയുള്ളൂ. We find out H plus concentration. എങ്ങനെ? It is given H plus into OH minus is equal to 10 raised to minus 14. We can find out H plus. H plus കണ്ടുപിടിച്ചു. അത് എത്രയാണ്? 10 raised to minus 14 by 10 raised to minus 4. It is equal to 10 raised to minus 10. Now what is pH of this? pH is equal to minus of log H plus. H plus concentration ഇപ്പോൾ എത്രയാണ്? 10 raised to minus 10. So minus of log 10 raised to minus 10. What is minus 10 raised to minus 10? Or minus 10. Minus of minus 10 is plus 10. Now the pH is 10. Neutral pH എത്രയായിരുന്നു? 7. If I add the solution became basic, then what about the pH? It became 10. So if pH is increasing, the basicity will increase. മാക്സിമം എത്ര വരെ പോകാം? 14 വരെ പോകാം. അണ്ടർസ്റ്റുഡ്? സോ pH if 7ലേക്ക് കുറവാണെങ്കിൽ that will be acidic. 7ലേക്കാൾ കൂടിയാൽ basic. അപ്പോൾ ഒരു സൊല്യൂഷന്റെ pH നമ്മൾ കണ്ടുപിടിച്ചാൽ if it has pH less than 7 ആണെങ്കിൽ ന്യൂട്രൽ, less than 7 ആണെങ്കിൽ acidic, then if it is more than 7 it is basic. ഇനി pH കുറഞ്ഞു വരുമ്പോൾ acidic strength കൂടി വരും. നേരെ മറിച്ച് pH കൂടി വരും, എഴുതുന്ന അങ്ങോട്ടേക്ക് കൂടി പോയി കഴിഞ്ഞാൽ അതിനനുസരിച്ച് basic strength കൂടിയാ വരും. So as pH value increases, the basic strength will increase. Understood?